All right, here we have a quadratic equation in sine theta. 2 sine squared minus 2 sine minus 1 is equal to 0. Okay, this one doesn't factor, so I'm going to have to use my quadratic formula. Let's take a look. I'm going to say this. Sine theta is going to be, okay, by the quadratic formula, negative b, so negative 2 is positive 2, plus or minus square root of b squared, so 4 minus 4 times a times c, all divided by 2a. All right, let's simplify here. 2 plus or minus square root of 4 subtract 4 times 2 is 8, times 1 is still 8, and a negative times negative is positive, so I have 4 plus 8, which is going to be 12. All divided by 2 times 2. So let's see, 2 plus or minus, square root 12 is the square root of 4 times 3, so I'll simplify that as 2 square root 3, because 4 times 3, that square root of 4 comes out as just a 2, all divided by 2 times 2. Okay, I just want to do this and simplify as much as I can. I'll factor out a 2. 2 times 1 plus or minus square root 3, all divided by 2 times 2. Okay, finally those 2's divide out, and so I'm left with this simplified expression, 1 plus or minus square root 3 all over 2. And that is my sine theta. Sine theta is 1 plus or minus square root 3 over 2. Okay, so let's take each one of these separately, and let's see, I got enough room? Yeah. So I'm going to do this. 1 plus square root 3 over 2. Okay, that turns out to be, let's see, I did it over here, 1.36. Okay, that won't work. 1.36 isn't going to work for sine theta because sine theta always has to be between negative 1 and 1. It can never be 1.36. So that's not going to give us any solution. Let's try the other one here. 1 minus square root 3 over 2. And so that comes out to be negative 0.366. Go off the screen? No. Okay, so I'm okay. Okay, so sine theta is equal to negative 0.366. Now, what are we going to do with that? How are we going to find sine theta from sine theta equal negative 0.366? Well, if you put this negative number into your calculator, press the inverse sine button, you'll get one solution. But there's actually two solutions. So what I suggest is that you forget the sign right here. Change that back to positive. Enter just the number here itself into your calculator and find the inverse sign of that. When you do that, what you end up with is this. Okay, I'm going to take it over here, and I'm going to say this. You end up with the reference angle of 21.5 degrees. So I put in the positive number right here, the absolute value of this number, press my inverse sine key, and what I come up with is 21.5 degrees. That's the reference angle. Now sine theta turns out to be negative, the negative 0.366 in quadrants 3 and 4. So let me see if I can draw that in real quick. So I want in quadrant 3 a reference angle of 21.5. Okay, so that will be this. 21.5 degrees, and then I also want it in quadrant 4, so I'll go over here, and that will be my 21.5 degrees. Okay, so what do I have? I have two angles that I'm looking for. One is this angle, which comes around here like that. So that's going to be the angle 180 degrees plus 21.5. So 180 degrees plus 21.5 degrees, and that ends up to be what? 201.5 degrees. Okay, there's one of my angles. The second angle is this angle. The angle in quadrant 4 with a reference angle of 21.5. Okay, that's going to be 360 minus 21.5. And that comes out to be, I think, 338.5 degrees. So there's one solution right here. Here's my other solution. You have to be careful on these problems because when you end up over here with the negative 0.366, you just go ahead and put inverse sine in your calculator, see what you get. You'll get one of these angles, but you won't get both of them. So what I suggest is forget that sign right here, do the inverse sine on the absolute value of this. That will give you your reference angle of 21.5. Once you have that, then you know that the sine function is negative in quadrants 3 and 4. You draw your little picture right here and you'll get your two angles out. Okay, cosine of a minus 50 degrees, that quantity is equal to square root 3 over 2. Well, we know with cosine is square root 3 over 2 that the angle must be 30 degrees, the reference angle. So I'm going to say this, a minus 50 degrees, okay, the reference angle for that is 30 degrees. So the reference angle is 30 degrees. Okay, and then cosine happens to be positive in quadrants 1 and quadrant 4 because cosine goes with the x-coordinate and x is positive in quadrants 1 and 4. So let's draw our little diagram here. I want a reference angle in quadrant 1 of 30 degrees, looks like this. And I want a reference angle in quadrant 4 of 30 degrees, looks like this. Okay, so where are my two angles? Well, my one angle is right here, okay, 30 degrees. And then my other angle is right here, which is 360 degrees minus 30 degrees, which is 330 degrees. Okay, so that tells me that this angle that I want, this A minus 50, is either equal to 30 degrees or a minus 50 is equal to 330 degrees. So if a minus 50 is 30 degrees, I add 50 to both sides. Whoops, let me put my degrees in here. A is equal to 80 degrees. Or in this case, I add 50 to both sides. I get A is equal to 330 plus 50 is 380 degrees. But now I'd like to write my solutions between 0 and 360. So 380 degrees is actually coterminal with just 20 degrees, right? 20 degrees plus 360 degrees is going to be 380 degrees. So I'm going to go up here and write my two solutions this way. A is equal to 80 degrees and A is equal to 380 minus 360. I'll take that coterminal part off and just get 20 degrees, and then if I want to write all solutions, I'll take these two angles right here and add on multiples of 360, plus or minus 360 degrees times k. So every now and then you'll end up with a solution like this that goes past 360 degrees. Just subtract 360 degrees from it and you'll get your angle from that, and that gives me all the angles between 0 and 360 that are solutions. Adding on multiples of 360 degrees gives me all solutions to those equations.